Hi there. I just wanted to cover a little bit of the information on percent change. I have another video when we get to the later unit on osmosis as well, so you can watch that too. I just wanted to cover some items kind of specific to this. So this is the formula, and that does stay the same for your percent change. It's ending value minus starting value divided by starting value times 100, and the 100 converts it to percent. So why do we do this? Well, we use this because when we have ending and starting values that are different, and that is very common when you're collecting data, sometimes it's hard to tell which worked better, which were the same, which weren't any better, because sometimes you can't always compare what the relationship is. So for example, when you look at this first one, you see a change of 15 to 12. That becomes the ending value. However, when you look at maybe like 3 is kind of easy to tell, right? That went 13 to 18. So maybe you can say, oh yeah, that changed a little more. But it also depends on how big your sample size is too. So the percent change kind of adjusts for that. And then this last one, again, the numbers are pretty different than the first one, the kind of starting and ending numbers. So it's a little bit harder to tell. The other thing that percent change does, which is really nice, is it gives you a sense if it's a decrease or an increase. And we use a positive or negative sign to show that. And sometimes too, you can express it as increase or decrease instead. So that both works. Okay, so let's do this example here. So this one is asking you to calculate the percent change for group 1. And remember, that's our control group. And we need that, right? Because we need to compare that to the other experimental groups to see if there was any change. So end value, you can just write start value for short, starting value. Okay, and then we're going to multiply it by 100%. I'm out of space here, but we can squeeze that in. That kind of comes later to multiply it by the 100%. So over here, the end value is, let's look, right? So you have to look. So you have before and you have the end value. Okay, so the end or after the experiment is over is 12. And we're going to subtract that from, if we want to put a unit on it, we can put details, right? This could be something like blood pressure or heart rate. Could be lots of different things. So in fact, I think we do ask you later on in the term to look at things like heart rate. Okay, so 12 minus 15 details. Now, in order to adjust it for kind of the sample size, I'm going to divide it by that starting value, and that's our 15 details. Whoops. And then divide that by 100 eventually. Okay, so when you first do this, you're going to get 0.2. So you'll get 12 minus 15, but I wanted to kind of break that down a little bit. So that's going to give you minus 3 over 15, right? So all I did here was I subtracted the 15 from the 12 and then divided it by my starting value. I just copied that down there. And so we can keep our units there if you want, although those kind of cross out because we have details over details. And then we're going to divide it eventually by 100 to get our put it in percent form essentially. But what I wanted to point out here before we do any of that is already when I did this first subtraction, I had a higher starting value and it actually went down over time. So that's a decrease. And the way that's shown here is you get a negative sign, like 12 minus 15. So again, you can write that as a negative percent. It'll come out as a negative percent at the end. And sometimes you're specifically asked on the quizzes to express it that way. I usually put a note there, and that's just so the system will mark it, and it'll know kind of what everybody's saying, and we're all saying the same thing. But you also can use the word decrease a lot of times too. So if you get marked wrong on something and you said, hey, I said 3% or 2% or 20% decrease, that's fine. So always check that and make sure that you've gotten that mark correct, even if you didn't put the sign. As long as you use the word decrease, that'll work. Okay, so the negative 3 divided by 15 is going to give us negative 0.2. So all we did here, it looks complicated. We just did a simple subtraction here in the top and divided it by 15. So now it's in just kind of a decimal form, and I want to multiply it by 100. Okay, and these units have kind of crossed out. It's okay, but you would just say the percent, and that's going to give me a negative 20% loss, right? They lost their ability to recall details, and this is the control group. So what we're asking you to do as you get to the post lab is to compare that to the experimental groups and see, obviously you can see they did better, right? They went up. Okay, so that's an improvement, you know that. But which one is the best? Was it, the low caffeine, kind of moderate, high caffeine? You might just assume it's the high caffeine, but you need to run those and see. And so like for this next one, it would just be 12. I'm sorry, let me go backwards. It would be 15 because that's the end minus 12 divided by the starting value. And here the starting value would be 12. So you see how all those numbers have changed a little. So by getting a percent, I could compare that. So one of the things when you look at, let's say, for example, you're looking at coronavirus cases, right? And you might say, oh, well, this state, like New Mexico, has this many cases, but then you might say, oh, California has this many cases. Well, you can't really compare just number of cases to number of cases in terms of how prevalent the disease is because the population is so different. So often what it will be presented as what's called a positivity rate, and that is actually just a percent. So they're just comparing two totally different sample sizes to each other. Or sometimes you'll say there's a certain number of cases per 100,000 people, which easily switches to a percent as well. So it's a way, again, to compare numbers that are different by just putting it in the simple percent form. So don't forget, you could also write this as a 20% decrease as well. They actually remembered less with no caffeine at the end, or their placebo effect, which had no caffeine in it. So anyways, that's kind of how you set that up, and it's always set up the same way. So it's always ending minus starting divided by starting, and remember the 100 is literally just to convert it to percent value. So this is giving me some information here, but that's not super easy to read. So we multiply it by 100, and then people can relate to 5%, 10%, 20%. It's just a little bit more tangible for people to get a feel for what the change is. All right, that is it. I hope that is helpful to you. Please let me know if you continue to have questions or want to meet on that very common question. So don't worry about asking about that because it is one that commonly comes up, and we do use it throughout different science classes. So, but hopefully it'll help you if you see something in the news too. Now you'll think, oh, okay, that's why they have to show it in percent. They can't just use a raw number.